All right, good morning and welcome back to another class of web and mobile systems. We are going to continue our discussions in the React Native library that we had started in the last class, which was basically to talk about the environmental setup and how we are going to develop our React Native projects locally, so to speak, using Visual Studio Code, right? So we went through the process of installing what we call as the Expo CLI, or the command line interface, which will essentially be used. It's an external package, that an environment that will be used to wrap our React Native projects. And then through Expo, we are going to compile and build our React Native projects, essentially, that will eventually can be deployed either on the Android platform or on the iOS platform, right? We also saw how to create our first Expo project within which our React Native project will be kind of hosted. So that can be done using this command called npx create expo app, and then giving a folder name to wherever you're going to be storing all of your project documents and stuff like that. And in order to start the project, we simply execute the command expo start, which is a global command. If you want to start this locally, then you would have to give some identifiers that will specify that you're starting it locally. But for now, we can just pay attention to the fact that in order to just execute your project, in order to start the server, we essentially are going to use the expo command and just hit start. Once you do that, once you hit expo start, it kind of gives you this QR code, which can be used with the Expo app on your smartphone devices or on your handheld devices. And you can scan this QR code. And as long as you are on the same Wi-Fi network, that is your local system where you are kind of developing your React Native project that is wrapped by Expo, and your smartphones on which you want to kind of visualize what your app is going to look like, then you can simply just use your smartphones to scan this QR code using the Expo Go app. And then that will show the execution of the app that you have built live on your smartphone devices itself, right? If your smartphone devices are not on the same Wi-Fi network, then you have to set up a tunnel in order to kind of tunnel into the network where your actual local system is, where you have done the development project. And then that will also enable you to view your projects on your smartphone devices platform as well. But in a situation where you don't have smartphone devices, then you get these different options for simulators that can be used. So you can either view it on the web, but that kind of defeats the purpose of developing a native platform application, right? If you are going to view it at the end of the day through a browser, then that's not what we are going after. That goes into the domain of web platforms, right? So Windows devices typically get the option, Windows and Linux devices typically get the option for an Android simulator. And then if you are on a Mac operating system, a Macintosh or a, what do you call it? iMac. I forgot the name of the laptop, what they call the MacBook. Yeah. So if you're on MacBook, then you will also get the option for the iOS simulator, which is known as Xcode. The software is known as Xcode. I don't see that option here because there is no way that I can set up a Mac simulator without a Mac operating system as such. So for those who are working in Macintosh, you should be able to, when you run expo start command, you should also see another option where it will give you that if you want to view this project on a iPhone simulator or a iPad simulator, then you can use Xcode essentially. So the first thing that we are going to do before we move forward with today's discussion, because it will take time, so those who would want to work along with today's topic, go ahead and first install Android Studio. Okay, so you can refer to the slides, the second part slides, which is available on Moodle as well, which will walk you through the process of setting up Android Studio. And for Mac users, instead of Android Studio, Mac users can also install Android Studio. That is available for them as well. But specifically, if you want to test out your application's deployment, test it, what it's going to look like on any of the Mac devices, then instead of Android Studio, you need to kind of install this particular software that is known as Xcode for Mac OS, which is available from their marketplace there, right? So pop open the slides, go to this link, developer.android.com/studio, or you can simply just Google search Android Studio. And the first non-sponsored link that you get is basically where you will have the option to download and install the Android Studio IDE, right? So go through it, go hit next, okay? It will tell you to check the prerequisites of what are the system requirements and what are the minimum system requirements that are necessary. Please note that this is going to be a computationally intensive application depending on the type of system that you're using. So you can see that you need a minimum 8 gigabytes of RAM, you need a minimum available space of 8 gigabytes. But from experience, I can tell you that this 8 gigabytes of available space, you would need at least like around 20 gigabytes once everything is loaded and ready to go, right? So go through this and then install your Android Studio, the whole thing. Okay, and it gives you the instructions for Mac OS as well in between. If you're downloading it for Mac, if you want to do it Android testing on Mac itself, then you can do it as well. And I believe nobody right now is working on a Linux system. Is there anybody who is working on a Linux system right now? Okay, I will assume no. So if you are working on a Linux system though, you also have the option for working with Linux and stuff like that. So click on any one of the Windows download options here, okay? And then go to this download Android Studio page, or you can click on the direct link that is provided in the slide itself. It's going to be a 1 gigabyte file. So as we discuss our other conceptual stuff of the React Native library, by that time, your installation should be done. So right now, you should go ahead if you would like to work along with today's project. And if you're not testing out your application using the QR code that I had shown the last time, then you would need some sort of a simulator in order to kind of deploy your applications. So it would be wise for us to kind of start that download process right away. And then for Windows, at least, it's going to give you an exe file. So you can simply just double click and go through the prompts. So if you go forward with the slides as well, from slide 5 onwards, I have also listed the screenshots of the different prompts that you're going to get for the first time setup of Android Studio. So please follow those prompts and set up your Android Studio environment so that we can essentially launch the navigator or the Android Studio emulator, sorry, not the navigator, and then deploy our Expo apps to that directly, okay? So please go ahead and start that operation as we discuss the rest of the topics of interest for today's particular class, right? So essentially you want to reach this point where you have the Android Studio IDE, okay? We won't use the IDE per se, we will use Visual Studio Code. The IDE is helpful if you're developing your Android applications in Kotlin or Java itself, right? So it helps in that situation. But since we are working with the React Native library, we won't need the Studio, but the IDE provides us with the option of setting up the emulator itself and not doing that separately, right? So once you install, go through the prompts, your goal is to reach to this particular window where you will see a window like this for your Android Studio, where you have your Project Explorer to your left, and then you will have your device manager options to the right. So get to this point, and once I discuss the overview of what we are going to talk about in today's class, I will come back to this and walk you through the process of setting up an Android device like what you see here for myself, right? So I'll just hit play here and give it some time for the emulators to kind of figure out. And this will take some time, and this might not go through successfully with the initial setup, depending on the specs of your system. It might take up certain time. So that is why we want to kind of get this process started at the beginning of the class so that we don't get stuck when we get to this point where we have to kind of launch a particular device. Okay. So, all right, so this is connecting to the emulator. My things are starting and I will just let it be for now and talk about what actually we want to discuss in today's class. Okay. So as far as the conceptual discussion is concerned for today's class, we are going to cover two important topics. Okay. One is, of course, specific to the React Native library, but another topic, the second topic that we will be talking about is a little bit more generic in nature, and that is not specific to the React Native environment. It can be applied to the React environment as well, but I'm going to show its implementation to you all using the React Native environment, okay, in order to kind of easily understand what we're doing, okay? So let's talk about the actual prototype or the toy example that we would like to go today, okay? So it's going to be very simple, nothing too complicated. The logic of what we want to implement is that we will show the users one screen. Okay, so we will call this, let's say, screen one. And in screen one, we will ask the user some sort of a question. Okay, we will have 2 or 3 questions, and these are going to be like MCQ type questions. Okay, and then the MCQ questions, we are going to implement that with the help of checkboxes. So we will ask them questions such as, if you want to take an example, it will be a question such as, pick your favorite programming language. Something like this, okay? Pick your favorite programming language, and then we will give them an option, and we will give them something like Python, or we will give them something like Java, or we will give them something like JavaScript, etc. Okay, that's the whole idea. So this is what screen one will present them. And then the users will be able to select one or more options, one or all of the options, whatever they want to select. There will be no restrictions with respect to choosing just a single option. They can select whatever amount of options that they want, right? So this will be the nature of a question that we will ask them. So it will be dynamic. There will be some user interactions involved. And the idea is once the user selects or provides their responses to these questions, to these options that are there, then our phones, and I'm saying phones here, but it is applicable to any kind of native platform, whether it is smartphone, whether it is iPad or Note, whatever it is that you want to use there, right? So once the user selects their option, there will be some sort of like a submit button that will be available at the very end of the Q&A structure. And then once the submit button is clicked, our screen will then navigate to the next screen. And let us, for now, just for the sake of discussion, call that as screen 2. And what screen 2 is going to do is basically going to give a confirmation of the responses that the user has provided in the first screen. So it will be something along the lines of a message or a prompt on the screen itself, which will say something like, you have given the following responses. Okay. So we can say that, and then we can say answer 1, your favorite programming language is, and then here we will give like a list, and that list will consist of the options that the user has picked. So if they have picked all 3 of the options, here we will give a list of all of the options that the user has picked. So we will say Python, Java, and JavaScript. And we will do the same for all the other Q&As that the user has kind of responded to. Okay, so as far as the logic of the program goes, this is pretty straightforward. And here we can give a back button, where you can say that the button, instead of being a back button, you can say edit your responses. So that will take them back to the previous screen or the home screen. which in this case is the home screen itself, because this is the first screen, or here we can just say okay. Okay, and once the user hits okay, then probably later on, if you do like a full-fledged with a backend environment as well, these responses will be submitted to the server, and that will be stored in a database against the user profile. Okay, so we are not coding the backend in this particular class, so we will just leave the functionality of this OK button to be like empty, so to speak, but the back button will allow us to revisit the first screen and allow users to change the responses if they want to do it. Okay, and if you want to take it a few more steps further, later on, maybe what you can do as a self-exercise is probably you can also give like a reset button. So what will happen if you hit the reset button, it will not only take the users back to the first screen, but it will also reset all of the different options that the user had currently selected for their responses, right? So this is the overall idea, okay? And now if you think of first thing that you need to ask yourself is, if I had to do this application using, let's say, the React.js library, how would I do it, okay? And that is going to be pretty straightforward. The first thing that you need to ask yourself when you're coding with React is whether you are going to create what is known as a single page view front-end application, or whether you're going to create this multi-page view application. Okay, regardless, it doesn't matter, because at the end of the day, React is going to kind of render only the changes that is going to take place in the state of the variables for our different components. And it is going to re-render the UI without any redirecting of the URL for the next pages that is going to exist for our web application. Okay, so this kind of is taken into account if you're trying to code this using React, let's say. Now, next, how are we going to set up the screens, right? The screens in the mobile application. So we don't have any concept of pages on our native platform. So what you call as pages on the web platform, we call as screens on the mobile platform or the native platform itself. So although React doesn't have any concept of screens itself, so what you're going to do based on our discussions that we already had about how to build a React.js interactive and dynamic project is that we will have components, okay? And then we will create two such components, one component for the first screen and one component for the second screen, basically the functionality that is to give questions, display questions to the user that will be inside one component, one functional component, and to show the results to the user, it will be inside, or it will be coded as another unique component altogether. Okay, and then we will kind of consolidate all these components in the landing page, which is, or basically the landing file, which is app.js, which kind of consolidates or brings together all of the different components in the correct order of their invocation. And then we will pass this app.js to the index.js file, which is kind of connected to the index.html file in a React project, right? And then we can give all the CSS stuff, whatever CSS that you want to do. I leave that up to you guys. I'm not going to be discussing too much about the CSS aspect of it, but you know that you can provide different like presentation rules, styling rules in order to make your app more presentable, so to speak, okay? So, and then we already know about event listeners in React itself, where you can do on click. Okay, so here this could be on click because we are doing on click, or specifically for checkboxes, it will be on change, right? So that is the state, or that is the event that you're trying to track. Remember in the text, we were doing on key press, on change and stuff like that. So here you can also do on value change, on change, and we had already discussed all of the different frequently used components that can be seen in React forms. So essentially we know how to deal with checkboxes. So all we have to do is basically bring that code in and use that in the event listener section for developing this MCQ kind of interaction, for making the button invoke the next component and things like that, right? So we have a pretty good understanding of how to do this in React, right? But what are the changes that are going to take place if we move to the React Native environment. Okay, so that is the first thing that we need to kind of identify and discuss, so that we can implement the rest of the stuff that is going to happen here. Okay, so functionality wise, and when I say functionality, I mean writing this question, giving these options, applying event listener to each of these checkboxes. Remember, we have to track the events that can take place on each of these checkboxes and not a single one. So those things, and then taking the data that has been given by the user, which is which checkboxes the user has marked, and then displaying exactly those options in the second screen. That is something which is React based, right? This is not a implementation that will be specific to the React Native library, but it is something that we are aware of how to do it or how to implement it in React. So we don't have to worry too much about that. Where we have to start worrying though a little bit, and what makes it new in the React Native library itself is, first and foremost, let's talk about the first thing that is different in the React Native environment, is there is no concept of pages in React Native. Okay, as we have discussed, we are not accessing our applications through a web browser, and it is going to be a native platform app. So when you think of apps, right, when you're installing your apps and stuff like that, there is no concept of HTML pages. There is no concept of web pages. Okay, so what there is a concept of, which replaces the concept of pages from the web system, is the concept of screens itself. And then we need to understand how to perform navigation across these screens. Because if you think about it for a second, let's say you have this HTML page here, okay, and there is some element within your interface that when you click it will redirect the users to another page, and let's call it page 2, let's call this page 1, and then let's say this is a button B1, which if clicked, it could be a navigation bar tab, whatever it is, it could be a button, however you want to do it, right? It could be a text link and stuff like that. And this will be taken to the next page. The easiest and the most simplest way to achieve this interaction, this reloading of the URL with a new URL specified when the page reloads, or telling the browser to kind of host this new URL that is provided. This is essentially done in plain HTML, right? In simple HTML, if you remember the first days of our classes, using the anchor tag. And the anchor tag has an attribute of href where you provide the URL of where the browser needs to redirect, right? And then the new page gets loaded. But if you think about it here, if you're in a native platform environment, there is no concept of HTML at all, right? So you cannot use an anchor tag as such and then navigate, because the moment you use an anchor tag, you will leave the environment of your application and a browser will be activated on your mobile phones or whatever your device is, your native device is. And then you would open that new link that you have specified using the anchor tag in a web browser. So you will leave the environment or the boundaries of your application itself. So when it comes to navigation, we have to learn a new way of how to perform navigation for our native platforms, especially when we are working with the React Native library, right? So there are different ways, depending on the technology that you're using, how these screen navigations are implemented. React Native has its own stack navigator. That's the package that we are going to be using, which will essentially help us implement this navigation. And the reason why it is called a stack navigator is because if you think about it, the Android operating system itself, it works as a stack, right? So what I mean by that is that the operating system application, the running applications that are there in the operating systems are kind of stacked on top of each other. So every time if you kind of want to delete or close an application, what happens is that that application is kind of popped from the stack. And then whatever the next application is, that is what gains the attention of the operating system, and the operating system keeps track of all the different stacks that are present in its container, right? So the same idea applies to kind of managing of how your application will be viewed by the user as well. It is in the form of a stack. So what happens is that you can think about it in this way, that once your application loads onto the user's screens, right, the very first screen that is there is going to be pushed into the stack container, right? And whatever is at the very top of the stack, that is what is going to be accessible, right? If you remember how a stack data structure works, it's basically first in, last out, right? That's the policy that is there, or last in, first out. However, LIFO is what essentially people refer to. So let's say when our application load, what is going to happen is that this particular screen will be pushed onto that stack. And whatever screen is at the very top of the stack, that is what the user are actually going to be interacting with, right? Whatever aspects are there in that particular screen, okay? So then when the user clicks this submit button, what needs to happen is that our compiled React Native application should take the next screen and then push that onto the stack on top of the previous screen. Okay, so this will become screen 2. This was essentially screen 1. So now, since screen 2 is at the top of the stack, this is what the user will be able to view, right? So the user is always viewing the top of the stack. So once you hit the back button, or let's say if you hit the reset button, then this screen will be popped from the stack. And as a result of that, the current state of the stack container has screen 1 at the very top again. Okay, so then the user will be viewing screen 1, which is basically the first page, as we discussed, based on the logic of that we're trying to implement, right? If you hit the OK button, maybe, let's say for discussion's sake, there is another screen, screen 3, which will tell us that your data has been successfully submitted to the server, or there was some sort of an error in trying to submit your data to the server. So please try again, something like that, right? And then that can be screen 3 here, which will be shown to the user. If it's successful, you can hit OK, and the OK will take you back to the home button. So essentially that will pop this screen 3 and screen 2, and it will only show screen 1 again. Or if there is a retry button, then if you hit the retry button, then that will take you back again to the first screen, so which will have the same behavior, which will be screen 3 and screen 2 will be popped, and all that remains is screen 1, right? So the navigation is a little bit different when it comes to working with native platforms, because you cannot use the straightforward web page navigation using anchor tags as we have seen in HTML, right? Because there is no concept of HTML here when developing native platform. So that is the first thing that we are going to talk about. And of course, we will talk about some of the basic components. If you remember from the React documentation page, there are like 20 odd new core components that React Native uses for various purposes, right? So those are mostly available in the documentation itself. So we don't have to like get frustrated about it as such. We just need to see that, okay, what do we want to do? We want to create a list of questions and stuff like that. Let us go ahead to the documentation page, visit those components and figure out which one is best suited to create a list, right? We want to create a button, let's figure out. The second thing, which is interesting, is the reason why we are going for checkboxes is that from that list of core components that I'm talking about from the React Native documentation page, there is no support for checkboxes. There is no inbuilt support for checkboxes, right? So you can implement a button, it's straightforward. You can implement an input text field, that is straightforward, where the user can type some information in, but when it comes to working with checkboxes, when it comes to working with radio buttons, we don't have any core support from the React Native library, okay? So we have to resort to finding out some third-party packages that will help us implement the concept of checkboxes within the React Native environment, right? So, and the problem with that is that there is no set third-party package which does that, right? So when I was trying to find those things out, I found that there are like 2 or 3 third-party packages which helps us implement this, but those don't work because those libraries are not maintained anymore currently. So it is outdated. So it gives us error, or it is deprecated when you're trying to incorporate them in your packages. And I will walk you through the bug process as well that I faced when trying to implement this checkboxes as well. So, and then arrive at the actual package, which eventually helps us implement that particular project, implement this particular functionality. So that's the second thing that I will be talking about. And the last thing, as I said, that we will discuss in today's class, which is not specific to the React Native library, it can be used within a React environment as well. And that is basically the concept of global state management. Okay, so global state management, MGMNT. Okay, and in order to do this, we are going to use another third-party provider that is known as the Redux toolkit. All right, the reason we are going to touch upon this is when we were performing state management in React library, okay, what we learned using the use state React hook was essentially local state management. And when I say local state management, that means we can essentially update the state of the data and access it only within the component where that state has been declared, right? And that state could be any type of data that we are trying to track using React, right? So that was local state management. The problem, or the, I wouldn't say problem as such, because you can work around it, but where it gets tedious is when you have to take the state of a given component and have to pass that to another component and track it there, right? So what I mean by that is, let's say, for example, if this is one component and you have these MCQ options, so these are all inputs that will be provided by the user, and you have to be able to track the changes to those inputs that the user is providing. So that means you need to create a variable, essentially, which can be wrapped around an object for each of the options that you provide to the user, such that if the option, if the user, let's say, check marks this and leave these two empty, then that particular variable for Java will be set to false. As an example, JavaScript will be set to false, but Python needs to be set to true, right? Because the user has checked this. Similarly, if the user checks Python and JavaScript, then Python and JavaScript variable will become true in the state container, and then Java will remain as is, right? So we know how to do that within useState, and then as long as we remain within this particular component where we are tracking the state, we can also access the most up-to-date value of our state variables, right? But now, imagine this scenario. Now we have to take the state of this particular component and pass it to this second component where we have to kind of output or render the options which are now true. Okay, the only way that we can give the confirmation of the user responses back to the user if we, as the developer, we know what options the user has actually picked, right? And to know what options the user has actually picked, we have to find out from the state container, which is tracking all of these different options, which options or which variables are true, right? So that is basically an if-else statement. In terms of implementation, it is straightforward, right? So we will only write an if-else statement that if the variable is true, then print the value of that particular variable in the list for this second component, right? What becomes, or where it gets to be a little bit tedious, is that we will have to take the entire state of this component, which is owned by this component, and we will have to pass that state to this second component here, okay, such that the second component can actually access the value of the variables within the state container. Okay, so remember, when using useState, it returns us two different values, right? One is the container itself in the first index of an array, and then we get a setter function, which is to update the values of the state container. Now, notice here, there is no getter function. So you cannot call the state variables from a different component because there is no getter function that is given. It's just a container. So you will have to self-reference the container itself and then access it. And the container probably is an object, or the container is probably an array. It's an array of objects. So here, typically, since we have multiple variables, in Boolean fashion, we are probably going to create an object which will wrap all the different options. So we will just say answer for question 1. That will be the name of the object, assuming, right, hypothetically speaking, and then you will have all of these different options there. Okay, and that needs to be referred to. So that object needs to be referred, and then we can access the individual keys and figure out whether it is true and false. So in the absence of global state management, one of the straightforward way of implementing this situation that we have here is when we pass this value, or when we call this particular component, we have to call this component in a nested fashion from within the first component, and we will have to take the state variables and we will have to pass it as a prop to the call of the second component. Okay, and that is very tedious, is because now if you start putting components one after the other here, so let's say you have a third component, a fourth component, a fifth component, which all needs to use the value of this initial component's state value, right? State containers value, then you would have to nest the execution of the component call within this particular component such that you can pass the state variables as a prop to these components which wants to use the value of the first component. Okay, there is a lot of back and forth here, so try not to get confused. Visualize what is happening. Okay, that is the important thing. So that is the first challenge, or that is the first part where it starts to get tedious, is how to take the value of a local state and then pass it along all of these different components that wants to use those values. The second challenge is going to be this setter function that is returned by the useState hook is accessible only within this particular component. All right. So let's say now, instead of just reading the data, if you're just reading the data, you can then pass the state as a prop and then call the component, and then the values will be accessible. But what if in a situation where I would have to take these values, which has been modified and it is owned by a different component, and I will have to make changes in that component. So let's say I had to make some changes to the input that the user provided, and then I would have to update the state container, which essentially sits in a different component altogether. We cannot access the setter function because the scope of this setter function is basically this component itself. So we cannot call this setter function inside component 2 in order to update the state which is owned by component 1, right? So that means now we have to make the changes, and we will have to pass that as a prop back to the first component, then call the setter function, and then update the state variable. So you can already see that the number of steps we have to take to perform a simple update operation or even a simple read operation is actually a little bit complicated. So instead of doing this, the solution to make this more simplistic, so I'm going to remove this canvas. Okay. So in order to simplify this whole execution, so let's say we had component 1 here, component 2 here, component 3 here, and so on. Let's say component K, and there is multitude of components here, right? And then the state that we are trying to track and update is owned by this component. And then all of these different components wants to read this state, and they want to perform some sort of an update or write to this state, and it needs to be preserved. So what we do is that instead of creating a local state management using the useState hook, we wrap our data, or we wrap our entire application inside this data store. And that data store can link with this particular container here, where all of the state will be stored, right? So that means if there is a state for C1, let's say that is S1, we will store that in the data store. If there is a state in C2 that is called S2, we will store that in the data store as well. And then we will split up the data store into what we call as different data splices. And all the splices are indicative of are basically states that come from different components. Okay, that's all there is. But you can think of this as like an apartment which has different rooms, and each room has a different state value inside of it, right? But the whole apartment is what the data store is. And this data store wraps our entire application, okay? And there is basically this bidirectional line of communication between your application and the data store and whatever splices you have, right? And what this data store helps us create is basically a set of global getters for read operation and setters. So if you remember, when we were talking about local state management using use state, we only had setters and then a container which can be directly referenced using the name as a label, okay? But instead of having that, when we use a global state management, like this is the structure for Redux itself, all right, what we end up creating is basically global getters and setters for each of the data splices and the state that is present inside of it. Now you can kind of visualize that the process of accessing the state of a different component within another component becomes much easier. So now what will happen is that anytime, let's say component 1, there is an update to the state of component 1, which is S1. So in order to update that state, within component 1, we will invoke the setter for this particular state, and that setter will send that update to the data splice, which is storing the values of the state of component 1. Now, if component 2 wants to read the value, the updated value of state 1, okay, we do not have to call this component within this particular component and pass the data value as a prop. All it needs to do is take the getter for S1 and then make a call to the data splice, which is storing the most up-to-date value of state 1, okay? And now, once this is accessed, component 2 can operate on the value of S1. And let's say some changes were made to S1. So it needs to be updated here in the data splice for S1. So all it needs to do is now call the setter for S1 and then pass in the new value back to the data splice, which is storing S1. So that means if component 1 needs to reuse the value of S1 at any point of time, then it can simply call the getter again and then grab the data value from this state. So instead of having multiple operations here, instead of nesting the execution of component invocations within each other, what we do is we kind of interact with this global state manager, right? And what happens when a setter is invoked? Well, this is kind of important because when a setter for Redux is invoked, it executes a dispatch. Okay, and within the dispatch is where you have the parameters of the setter function. All right, and once this is received by the data store, so on the data store side, all right, once this dispatch is received, this dispatch is broken down into two different criteria. One is the action, and second is the state itself. All right, so this is known technically as the payload. So payload is nothing but whatever parameters that you pass with the dispatch. And the dispatch, when it is received by the data store, dispatch is basically kind of like an instruction, right? You are sending a dispatch to somebody with some content in it. That content is technically called the payload. And the payload, for example, here could be a setter function. Since it's a setter function, it will further have some parameters within its function call itself. That parameter is going to be how to update the value, okay, that you're sending, right? So once the data store receives this dispatch, it tells it to do something. And that something is basically to look into this payload, figure out what is the action that needs to be executed and what is the state that needs to be updated, right? Updated or retrieved, okay? So in terms of actions, you can think of two things that can happen here. Either it will tell you to perform a read operation. So that means this is not a setter. This is going to be a getter in that situation. Or it will tell you to perform a write operation, you being the data store itself, right? So in that situation, here the payload will have a setter function when it is a write operation. If it is a read operation, then the payload basically consists of a getter operation, okay? And then the state will basically be extracted from whatever parameters is passed onto this function here, the setter or the getter function. So the state will be some kind of value, say set the variable Python to true. Okay, so that is the state information that is going here. So if it is a read operation, then it will not have set the value of Python to true. It will just say extract the value of the variable Python. So let's do it step by step. So let's say if the action is read, then the state that we will receive is just the name of the variable. And the data store will then, what it will do is it will go here, find out what is the updated value or the most up-to-date value within this container, and then it will respond back accordingly, right? Let's say if there is a write operation, then the state with the payload will have the updated value, which will say that set the state of the variable called Python to true, and then it will implement that action, right? So that is what is going to happen as a high-level overview when it comes to working with Redux. Now, Redux can be implemented with the React project as well, just the same way that we are going to do it in the React Native environment. That is the same way that you're going to do in the React environment as well, okay? It's just that you connect it to a different area. So that is all that there is to understanding React. So Redux, sorry, not React. So a few new technical terms that we have just introduced here and you have to remember is, first of all, dispatch. What does dispatch mean? Well, whenever a component needs to react, needs to interact with a Redux data store, which is basically responsible for containing all the data splices that stores the states of different components, then it executes a dispatch, and the dispatch consists of a payload. And that payload could be in the form of a setter function or a getter function, all right? Once that dispatch is received by the data store, it needs to figure out what action it needs to take and what is the state of the variable that you are trying to access or update, right? So if the action is basically a read operation, then the state is going to be whichever variable that you're trying to access. So once the data store figures it out, it sends that response back to the component that invoked this particular dispatch, all right? If the action the data store figures out is a write operation, so that means a setter function has been sent from in the payload, and then the actual state or the data within the payload is going to be how to update the value, or using what value should we update the state that we are trying to update, okay, or that the component is trying to update. So there will be no response in that situation from the data store back to the component because it's a write operation. You don't have to send an OK or anything like that, right? So you can think of this like a mini front-end, back-end interaction that is happening within your front-end itself, right? So once you understand this, state management becomes much more easier when you're trying to move your state data between different components, like we will see in this particular case, all right? And the last new terminology that we will learn when it comes to Redux, so here we will just put this here. So this is the discussion about the conceptual overview of Redux, is when you want to splice these data stores up into multiple segments, and each splice is going to be corresponding to a state of a given component, right? The way we try to create these splices is through the help of developing what we call as reducers. Okay, so the reducers essentially take all of these different states that we have, and they reduce it and they break it down and they combine it later on, and they provide it in the form of the getters and setters that will be available from within these data splices, right? So we have to establish essentially the data store. When we are working with Redux, the first thing that we have to do is we have to create the data store. Then we have to create the data splice, which will have the reducers within it, okay? And then we will have to go to the individual splice. We'll say individual splice. And then within this individual splice, we will have to first of all establish our getters, okay? And then we have to implement our setters. We have to take some steps to implement this. It will not be given back to us by default, as we had seen in the case of use state hook, there we were using the hook itself, right? So the hook was responsible for implementing these getters and setters. Here, we will have to write a few statements of code in order to implement these getters and setters, right? And then when we want to kind of use we want to invoke the Redux features from within our components, we will have to use two hooks, okay? The first hook is basically known as use dispatch. That will invoke this particular operation of interacting with the data store itself from the components. And then if we want to update a specific operation, then there is another one. That is, if you want to read the data from the data store itself, there is another hook that is known as use selector. Okay, so that will essentially allow us to kind of call the getter function here. So the dispatch will be taking care of the setter function, and then the use selector hook will be taking care of the getter function, the read operation, right? So this will allow us to invoke the Redux data store operations from within the components, okay? And outside of that, to build the data store, the data splice, and then establish the getter and setters for each of these data splice, we have to write separate piece of code. So this is essentially what we want to kind of work with in today's class. Okay, so let's move on to that environment and let's quickly start our coding process for this particular environment. And we will of course need a bunch of packages because we need third-party packages for Redux. We need third-party packages for the checkboxes. We need third-party packages for React Native navigation as well. Okay, so we need to have all of those different features. So yeah, as you can see here, my emulator has been stuck forever. So these are the things that I was telling you about, that you know, the React Native environment can sometimes get a little bit frustrating because there is no error here. We don't know what is happening. It's just a system issue that something is wrong here. So typically when things like this happen, the only solution that I have found to be useful, rather than breaking my head against the wall, is to just hit the restart button. So I just hit the restart button. Notice what I just did is that I hit the restart button for Pixel 4a, but when this thing started, I don't know if you all noticed, it said Pixel 6, right? So that means that that emulator was running, it just was not showing up. And the same thing is probably happening here. But anyways, the main thing is, are you guys done with your installation? It was somebody who was trying to install successfully able to install their Android Studio? Okay. All right. So a few things that I want to talk about Android Studio before we move forward is there are these two buttons at the top. I don't know if it will allow me to access that button while I'm working with this. I don't want to crash this application right away. So notice something, there are these two buttons at the very top right corner. Okay, so yeah, now it opens. All right, so notice this, that there is this one icon at the very top right, which is called Device Manager, and then one icon here, which is known as the SDK Manager. These are the icons of interest for us in this environment, okay? We don't care about any of the other buttons that we see here. Of course, we care about these ones, but these are just for information only. The rest of the buttons is for running a project here within this IDE, right? But we are interested in this device manager. And I really would wish that this thing starts to work a little bit smoother, but hey, what to do? Okay. And then the second button is basically the SDK manager. And the reason why these two buttons are important is because this is what is going to help you set up the Android virtual devices and choose the type of Android operating system that you want to use in order to set up your device. Okay. So essentially, if you go here and if you hit on the create device, it will ask you to select the hardware, right? So here you can select whether you're going to create an emulator for a phone, a tablet, a Wear OS, a TV, or an automotive. Is this thing up again? Okay, it's still not up. I think I should restart this whole stuff. Anyways, so once you hit the device manager, that's the first icon that I am talking about here, which eventually will open, I'm guessing, because it's stuck in the build process for some reason. And this is kind of going on and on as well. So once you hit the device manager, the first screen that you're going to be seeing is to select the type of hardware that you want to create the emulator with. So you can see here in the screenshot that is given, if it is viewable, it's a little bit, you have to squint your eyes a little bit, but you can select the phone category and you can select the different types of phone. Unfortunately, you're only going to get the option for Pixel, but hey, as long as you have an Android operating system, the behavior is going to may look different, but it's going to behave similarly across the Android platforms. You can choose tablet, you can choose your wearable devices as well, which is the Wear OS. You can even choose TV devices, some stuff like that. And if you want to build for automotive sector, that is, if you end up going as a application developer for automotive companies such as Ford, GM, which is about developing the infotainment systems and things like that, then you can test out your code for automotive as well. So you pick that, you go hit next, okay, and then once you go next, it will ask you to select a system image that you want to build. So that is the system image that we are seeing here. Okay, yeah, I'm not, this is not cooperating today. All right, so the system image that you see here, that is either Pixel 4a with an API 33 or either Pixel 6, those kind of things. So that is what you will be able to specify in the second screen of setting up your devices here, where you can select one of the different system images that is offered here. Okay, so pick the one that you would like. Try to be somewhere in between. Don't try to pick the most highest level, because sometimes it might not be the stable version, right? And don't select something that is way too old as well, because you need to know what type of operating system is being currently used by the average masses, because you want to test for all of the devices as much as possible, right? So once you set that up, then it will take some time to boot up. And then you will see these options here as I see it here right now on my stuff, but it will keep on repeating this. So yeah, we will just restart this. Okay, so you should be able to see this. So go ahead and create your devices while I restart my application here, and hopefully it will be a little bit more cooperating, which today is not the day, it seems, but we will figure it out. Okay, so that's the first step. The second step is basically you will have the Android virtual device, right? So you're not using any kind of like an actual device that is being set up. If you need to compare what you're doing here, you're basically setting up these virtual machines where if you have worked with things like Oracle VM player and stuff like that, where you download an image of Linux and then you upload that to that environment, and then it creates a Linux system for you, and you give it some RAM and you give it some memory and stuff like that. That is exactly what you're doing here with your emulator as well, which is creating an Android virtual devices by selecting a particular option. Okay. For first time installs, you might see that this window that I have that pops up whenever I try to create or kind of launch one of these different emulators show up in a different window. For first time users, you will see that window appearing right here at the bottom of the screen. So if you want to just get this out here, you can click on the settings button. Okay, even that is all right. So this is the reason why I prefer the Expo Go app, because it's much more quicker, because this takes up a lot of memory. All right, so you can basically move this around wherever you want to move this, and then if you go into the view mode of your virtual devices, then you can unpin it or undock it, and if you unpin or undock it, then essentially you will get that window in its own separate window, and you can see a bigger screen if you would like to do that as well, right? So let me try this one more time, the device manager, if it will work. Okay, here we go. So this is basically what you will see when you hit the device manager. You get the option for a lot of different Android devices along a lot of different categories. Remember, the behavior of your application is going to differ from each of these categories because the screen size and resolution of how your app needs to be presented differs a little bit. So this has a direct impact on some of the rendering of the components on how it will behave. So be careful about which platform you're developing your native applications for. If it is the tablet or if it is the wearable device, TV, automotive, and stuff like that. So you can see the infotainment system here. It's giving you an 8.4-inch infotainment screen, right? But not all cars have an 8.4-inch infotainment screen, but this is the only thing that is available here and stuff like that. So you can create from any one of these different pixel options that you can see here. Pixel 6 is currently kind of like the latest. I know there is Pixel 7 as well, but it's not yet there in Android Studio as well. So if you want to create a Pixel 6 API, you just select this. You can create new hardware profile if you would like to do so as well. That is, you can specify how the device is going to be set up. You can specify that here using this. If you already have that hardware profile, you can import it. Then you need to go next. It will give you the options for all of these different Android operating system versions or API levels. So select the one. I think Tiramisu is the one which is Android 12 and above. So that is the most latest API that is available. So you can select it. For first-time users, you would have to download. So you can see here on some of the API levels for the Android OS, I have this download button that is there, right? So that means that if I select and boot my Android virtual devices using these different operating systems, then it will download it and then it will set it up. And that in itself is going to take up a lot of space. As you can see here, each of these devices that I have, it takes about 12 gigs and 11 gigs of space. So that minimum requirement of 8 gigs, it's not going to work. Your device will essentially choke, right? I'm working with a 32 gigs memory right now, and my device is choking right now. So that is another complaint that I have with this, as to like, why is this not smooth, right? So if you hit next and if you hit start, then essentially you can give it a name. You can go to the advanced setting. You can check up any other options that you would want to set up. So if you want to design the app and test it for, let's say, in landscape mode, then your default orientation is always going to be landscape. If you want to keep it portrait, then you can keep it portrait, right? And here you can see you also have the options for emulated camera and stuff like that. If you want to choke the network speed, if you want to change the network that the user might be using. So these are all mostly for testing options for different conditions that can arise in the situation. So once you hit finish, it was going to take some time. And depending on your system specs, how much time it takes, it depends on that essentially. But it will install the whole environment. And then you should see an option like this here, okay? And then eventually, once you hit this emulator, and you can see this emulator is undocked right now for me, so I can move this window around. If you want this to be present, okay, there we go. Finally, all right. So if you want to set this up, I can go to the view mode, hit this settings clock here, and then go to the view mode, and then you can undock it. So for you, for first-time users, it will show up somewhere here. Okay, so if I undock it, then it will be shown as a window of its own. So I can maximize, minimize it. All right, I can basically stop this. Cannot. Okay, so this is the reason why it is not working. So this is from a previous testing that I was doing, essentially. So it was kind of behaving like this, right? So you have the screen operations at the very top. If you are working with an Android phone, you can basically use this back button here. You can use the home button here, or you can use the button that shows you all the open apps that are here, right? Or you can essentially use the screen options here as well. So that means if I need to drag down the notification bar, I can just click at the very top, left click and drag. So that will just show up here. If I do pull from the bottom like we do for our cell phones, that will show me all of the stuffs here. So I can just delete this by pushing it up, and that will clear up all my workspace. And then I will have the screen here, and we can use all of the stuff as if we are working on a cell phone itself, right? So This gives me a little bit of concern because it kind of retained the state from the previous execution. So hopefully it is able to find, Expo is able to find this emulator here and work with it. Okay. So what we are going to do is first and foremost, test this guy out first. So I'm going to hit Expo start here for this project that we're already in. I think we are in the wrong directory. So we would want to first go into this directory a little bit. So right now we are in React Hello World, and the folder which has my code is basically AWS code commit. So I'll just continue to use that. Okay, so CD into AWS code commit. Okay, and then within this, I will CD into my Expo application. So that is where my actual project is. And then I will just hit Expo start. And that will do the build process, start of our project, starting the Metro bundler. And all I need to do at this point of time with my Android emulator running, and let's pray to the demo gods, is if I hit A now, which is to basically open it with Android, then Expo should be able to find this device that is running and then load the application here. The first time compilation will take some time, or any major changes is going for which will require major recompilation is going to take some time, right? So if you have already understood the drift of where we are going with this, be patient, right? That patience is something that you will need a lot when working with this. So let us hit A and opening on Android. And let's see if it goes through or not. Okay, so it has already found this. Emulator is outdated. Would I like to update it or not? I will just say no for now. Maybe that is the reason why it is taking so much time. All right. And okay, it needs to download the latest from, so it would not even allow me to work with the stuff itself. All right, cool. At least I know what is wrong here. All right, so I need to update it on my side. If you guys just downloaded it now, then you should be fine. You should be able to upload it. So did anybody get to this point where you're able to click on the Android emulator and start it, or are you still waiting for your emulators? Any feedback, any notification? Anybody trying this out side by side? No? Okay. Still waiting for the emulator. Yeah, that's going to take some time. Okay, so we'll get back to this. Let's talk about the actual stuff. But before I go there, let me just do one thing. Let me just close this guy and start my server. And let me see if it gives me the option again for Expo. Okay, yes. All right, so if I hit yes, let this take care of it, and let us talk about how to set up our actual code itself. Okay, let's talk about the code that we're trying to implement. Let's learn a little bit about how to work with what do you call the React Native navigation and the Redux for global state management. Okay, let's talk about those things. All right, so the way I'm going to set it up is I will have components here. Cool. And then I'm going to go into my project directory, which is my Expo app. And then in this directory, I will create a new file here, which a new subfolder here, and I will call that screens. All right. Within screens, I will create two different screens, just like we discussed here in that previous canvas that we were talking about. One is going to be a file for my questions screen. So I will say questions. Question screen.js. So I'm going to create this screen first, right? And then the second thing that I'm going to create is basically an answer screen here. So I will say here in screens again, I will create another file and I will call it answer screen.js. And one thing to note here, just like we talked about in React itself, that the name of components will start with a capital letter. Remember, we are, even though in the JavaScript environment, so here our Expo app is running after I have updated my Expo version. If you guys work with Expo itself, and this is basically the app that you're looking at. So what happens here, that if you come here and let's do this, we need to have a side-by-side operation here and reduce this a little bit and probably bring it down here. So if we do something very simple like F2E or something like this, right? So this will refresh up, and that did not change it much. So let me change it to F4E. All right. So that is also not doing anything. So let's say, all right, so this is also going to happen. The refresh is not going to show immediately. So if you have a situation like this, all you have to do is basically stop the server, and then it starts to refresh, and then it says it cannot connect. Very true. And then you will have to start your server again. So basically the process is you need to close this guy. So click on this, delete this person, okay, and delete this person so it does not retain any of the state. And then you need to start here. So it's pretty good start. We have already hit all the bugs that you will be facing. So you wouldn't be surprised or by yourself when trying to encounter these bugs, or when you do encounter these bugs, at least you know what's happening with it, right? So things can be done here. All right, so waiting for this. So I will come back to this guy here. All right, so we have already created the screens. The naming convention needs to be, it needs to be on the first letters needs to be capital. In the components, I'm going to delete, or not delete this. Actually, I will delete this component because I don't need this anymore. Okay. All right, so open up app.js to work starting with your application. Let's say if I give a text here, all right, and say this is a hello world message. Okay. Yeah, this thing is not behaving at all today. All right, there we go. It takes time. All right, so this is the patient spot. This is not how it should work, but it should work a little bit more faster. But anyways, any changes that you make will be kind of reflected immediately. The moment you hit a save, it will recompile and it will throw it on the emulator itself. All right, so coming back to our components, we have deleted the previous component. Now we need two more files here. The first file, I will say question card component. Okay, question card.js. We can write it something like this, or we can give it a question component, whatever it is that you want to have there. So if you want to have a question component, if you have to question card, whatever way you want to write it, as long as you understand what you're creating, that is how the naming conventions will go about it. So this question card component will be invoked within this question screen. And then I'm going to follow the same suit, and I'm going to create an answer card.js component. And that answer card.js component will be executed in this screen. So let us go ahead quickly into question card.js and then create a boilerplate here. So React Native functional export with style sheet. So I'm going to create this for my question card. Okay, and then I'm going to do it for my answer card as well. So that means React Native functional export with style sheet object. So we will create this component as well. And all we need to do eventually, not at this point of time, but call these different components. We are going to write down the code for the presenting the questions and then presenting the answers within these card components. And then we are going to call these card components inside their respective screens, right? So that is the idea that we are going to implement here, okay? The next file that I want to create, so now I have taken care of my initial structure for my components and my screen. So the next thing that I need to take care of is this guy here. This is a little bit messy, but this data store here. So we need to have a file which our app, we have created all the files for our app. We have an app.js, we have created the components, and we have created the screens as well, right? So everything on this side, we have created those folders. Now we need to create some, we need to create the structure for our Redux environment so that can work out as well for us, right? So what we're going to do first, in order to work with the Redux environment in the root folder, okay, in the root folder itself, we first want to create a file that is known as store.js. That store.js will be the landing page of our Redux data store itself. So I'm going to go here into the root folder, and then I'm going to say store.js. Please note here, you will not start with a capital letter here. That only applies to your component names and your screen names, okay? And then not all the way. Now, store.js is created. And then what do we need? We need these splices. We talked about these data splices, right? So that is how we are going to divide it up. So in order to create the container for the splices, since there can be multiple splices for any set of project, right? So what we need to do is inside, again, the root folder, we will create a subdirectory here and we will call it splices, okay? Or sorry, not splices, it's called slices. All right, so we're going to create the slices here. And then within this slice, we can essentially create a file that will be responsible for storing each slice, okay? Or each segment that we create for state management, okay? So we know for this particular example that we are working with, there is only a state within the first screen, which is the answers that the user is going to provide, okay? So that means within the slices subfolder that I just created, I'm going to create a new slice and I will call that question slice.js, okay? So that will remain. So now I have my data store, which is going to act as the landing page for my Redux container. And then the data store will refer to the slices subfolder and then the individual slices that we have for different state management that we're doing. Remember, each slice will store a specific context of the data, and you can create as many slices as you want to create, right? There is no problem with that, right? So the first step is done, which is to setting up the project directory, right? We have done a good job here with respect to the project directory itself. So we have all of the different components, we have the screens. If you want to store media files and stuff like that, then we can present media files here. And then we have the data store, we have the slices. So all good to go, all right? So now we need another terminal. Let this thing run. Let us go to split terminal and open a git bash terminal. And this is going to remain in hello world again. So I need to get out of this cd aws code commit test. This is where I want to go. And then I want to go into cd my expo app. That is where I am currently. So the reason why we need to open this is because we need a bunch of libraries now. Remember, we said that all of this, that is Redux and then React Native navigation, these are provided by third-party packages. Even the checkboxes itself is going to come from a third-party packages. So we need to work with third-party packages. So we need to install those third-party packages. Now the way or the provider that I'm going to use to install my third-party packages is not going to be npm here, right? So we are going to be using yarn for these examples, right? In order to show you how yarn works as well, in addition to npm. So if you have not worked with yarn before, this is the first time that you're working with yarn, then you need to first execute this command, which is npm install yarn. So that is how it will create or you will be able to use yarn itself. So go ahead and install this, okay? All of these instructions are available. So if you're missing out on it, don't worry, don't feel anxious. All of this is available on my GitHub as well. And it is also well documented for React Native projects, step by step. So you won't be losing out on anything if you fall behind. But if you fall back, don't worry about it, right? That is essentially what I'm trying to say. So make sure you install yarn itself. And I think I have yarn set up already because I can see here in my project directory, I don't have an npm package log. I basically have a yarn log, right? So if you have set up your project using npm, particularly, then what would happen here is basically you would see a package-json.log file, right? So that is coming from npm. But if you see a yarn.log, that is when you know that yarn is basically managing this particular provider. Okay, so there are a lot of different libraries for checkboxes. So in the README instruction for the RN checkboxes, so basically the GitHub repository that I have is called RN checkboxes, right? So that is what we are discussing here. So if you go to my profile, if you look for this particular project repository, that is where you will find the README file, which will have the instructions, right? So we'll come to the checkboxes later, but what we want to start off with is basically how to implement the React Native navigation first. So we'll set up the navigation first step. Second step, set up Redux. Third step, finish the rest of the application. Because you will see that when the navigation and the state management is done, everything else becomes straightforward, right? It's just about what you want to do after that within your applications, okay? So the first thing, in order to set up our React Native navigation, we need to install a bunch of projects, a bunch of libraries. So for that, I need to stop the server. When you are adding something to the fundamental structure of your project, you need to stop the server, right? Because your server is going to crash at that point of time, regardless, right? So the first thing that I want to add here, not yard, but yarn add, that is how you install packages using yarn. Just like in npm, you say npm install and then the package name. In yarn, you say yarn add and then the package name. That's all the similarity. So if you understand how to use npm, you basically need to replace npm with yarn. You need to replace install keyword with add, and then the package name remains as such. Okay, so the first thing that we need to do, and I will put it inside this string command so that it does not kind of mess things up. So I'll just say React -navigation. Okay, this is coming from React navigation itself, by the way, remember, but we are using the native navigation aspect of this application, right? So hit this and React yarn will do its job. And it's a little bit faster than npm. Okay. So let it finish its operation. So once this operation is done, we need to kind of add this whole thing to expo now, because remember we added this package for our React Native project itself, but our project is wrapped in another container, which is the expo container. So for expo to be able to compile the React Native navigation stack that we will be using in our project, we need to build our expo project with the React Native screens and the React Native safe area context. Okay, safe area is basically this particular area here. So we don't want our app to bleed into this area, which shows your status bar, right? So that is what safe area is called in or referred to in this native platform development, right? So the way we are going to do it is, once we have installed this, we need to run the compile and build command, okay, download and build command for expo, and install this package that is called React Native Screens. Yarn doesn't have a command to replace npx, so we need to switch back and forth a little bit. So we are installing for expo now and not for our React Native project, this package called React Native Screens that will allow expo to understand this React Native navigation that we are going to build, and this React Native safe area context, which will hopefully prevent the bleeding of the app into this danger area, okay, which is basically the status bar that we need to work on. So a little bit of a side fact with the safe area context thing, there is actually a component in React Native itself that if you wrap your code around that component, by default, your application will not bleed into the safe area. It works amazingly for iOS devices, that if you drop this code on an iOS platform, it works just as intended. It doesn't work the same for Android. Okay, so that's another information for you. So we will run this, give it some time. Okay. All right, so npx will invoke yarn in order to install all its packages, because yarn is our package manager right now, and then it will compile and build. everything is done. And this is quick. I like this because it is this quick, right? And then we need one more package to build the stack. Okay, so we have taken care of the fact that, okay, we are going to do React navigation for native platform using the first command that we executed somewhere top here, React Native navigation / native. Then we installed and built for Expo the React Native screens. So these screen concept that we have developed, we are going to build that. So we have figured that out, and we added another package which is for safety purposes, so that our app doesn't bleed here into the status bar. And then the last thing is basically the actual package that is going to build the stack for the screens. Remember, we talked about the stack structure where the screens are pushed or popped, and that is what the user is going to see, right? So we need one more package, which is known as React Navigation Native Stack. So it's also a part of the React library, the navigation library, but it is for the native stack itself, right? So we are going to install that, and that is going to build all of these stuff. Okay, so once that is done, then we can start building our screen itself, right? The interaction between the screens itself. So that is going to become a fun activity. All right, so once everything is done, now we are kind of ready. So let me close all of these open tabs, which we are not using right now. So I will close everything but app.js. Okay, so now we are inside app.js. We can see here the status bar is kind of being imported from the Expo status bar package. React Native, we are getting style sheet. This is for CSS that is written using JavaScript. Text, in order to display any kind of text on the screen, we can see here. I probably need to restart this guy. So what I will do is, for the time being, let me just go ahead and not kill it for a change and see what happens. Anyways, all right, so text for text in a screen. All right. Okay, and then you have the status bar style auto, which is coming from this particular status bar here. If you remove this information, then this area will be kind of bled and stuff like that. So that is something that is happening there. And the style sheet already has some sort of a styling information here. We will leave it as such. Let us focus specifically on how to set up the navigation itself, right? So that is the last action we will do for today's class. And then in the next class, we will talk about the Redux part and finish off this application. And hopefully by that time, all of you will also have your emulators set up as well. If not, you can always use the QR code, by the way. The QR code is much better option. If you're developing by yourself, you don't have to show anybody what is going on. It is much easier to work with that operations, okay? So the few things that we are going to need here is, first of all, to create the navigation container, and then something that we call as the create native stack navigator. Okay, so we need the container first, and then we need the way to navigate that, right? So for that, we need two different objects within our code. Okay, so from all of these packages that we installed. So the first package that we need is known as the navigation container, right? We need a container that will store all our screens, right? So that is the stack container itself that is required. So that is known as the navigation container, this guy here. Okay, so the navigation container, we will import it from the React navigation native package, the first package that we had installed. Okay, now we need a way to be able to navigate between the screens that we are going to dump within this navigation container, right? So that is the second action, is that, okay, we have created the container. Now, how do we move between the screens? There has to be some kind of method that will help us achieve that operation, right? So that is something that comes from the native stack, or the third package that we installed in the set of 3 packages that we just installed. So we are going to import what we call as the create native stack navigator. So create native stack navigator, this guy here, from the React navigations library, sub-library native stack. So one is the container, one is how to navigate. Okay, the next thing that we need is to basically bring in our screens, because we need to navigate within the screen. So we need to pass in the screens that we have within this particular. So we know that the screens here are the answer screen and the question screen. So I need to import these 2 files into my app.js, which is the landing page of my file, right? So I'm going to import the screens. Yeah. So all you need to do to import a particular file within JavaScript is basically say import, give it the object name that you will refer to it as. So I will say the same name here. So I will say question screen dot not dot JS, and I will import this from essentially. So where I'm here, I'm in the root directory. So if I do this, then I go to my screens, and then within my screens, I have question screen. Okay, so that takes care of my first screen. And then I need to bring in the second screen as well. So import, and I will give it the same name. So I will give it answer screen.js from /screens. So let me just, okay. Did I? Oh, there it is. I made a typo here. So that is why it is not picking up what I'm trying to get. So I will go back to the screens directory. And then inside the screen directory, we are basically using this answer screen, right? So the screens have been set up here. Now, the thing is, the screens will show empty right now because we have nothing within these screens, right? But essentially the idea of what we want within these screens is basically a call to the components that we have, and the components will have the actual code. Okay, so the screens will basically be a React functional component. And remember, since we are exporting these screens here, so we need to also have an export statement within the screen file. Otherwise, export will not work. So I'm going to quickly go ahead and I'm going to do a React Native functional component export. We don't need style sheet here because the styling will be done in the component, which will be called within this screen. So we don't have to worry too much right now, at least about the styling of the screens itself. So I'm going to do that for my answer screen, and React Native functional component with export. And I'm going to do that for my question screen as well. So here we will just see these screen texts here, and we will probably see it at the very top somewhere here because we don't have any styling that centers it on the screen itself. So we are going to see this here. So I will finish this off later on with the component call here. We will pop back. So now we have some content in the screen. So now we need to build our stack, and we need to build our navigation within the stack. Okay, so the way we are going to do it is within this return statement here. Okay, so the first thing that we need to do within this application component is first create the stack object. Okay, so here we have the navigation that we have here. So we need to create a new instance of this create native stack navigator. Okay, so that is the first step that I'm going to do, create a new instance of the stack navigator. So I will call it stack, and then I will call the create native stack, and this is a method, and I'm creating a new instance of this method. So I'm basically referring to a constructor, and that constructor will be stored inside the stack itself, right? Now, in the return statement, which is what will be rendered on the screen of what the user is going to see, this is like a similar pattern across all our stuff. So I'm going to take this code, okay, and I'm going to remove it. All right, you will not see any update because my server is essentially not running. And the first thing that I want to do is I want to wrap the entirety of my application, whatever there is, inside this function component of navigation container. Okay, so that means I'm going to call this navigation container, and I'm going to put this here. All right, so the moment I put it, I have essentially now wrapped up my entire application within the navigation container. So that means whatever I have here will now be put inside that container. And now all I need to establish is how to navigate between whatever it is that I'm going to dump within my container. Okay, so now since we have that established, we need to create, using this stack object or this instance that we have created, we need to create a navigation. All right, so the way I'm going to do it is first start off with the stack object, okay, and then create a navigator. All right, and then I'm going to close this block. All right, so this will start enabling the navigation within the navigation container. All right, and what am I supposed to navigate? Think about it for a second. I created a container. It wraps my entire application. We are in app.js. App.js is the landing page. So the entirety of my application's logic is consolidated or brought together within app.js. I created a navigation container. I know stack is an instance of stack navigator that is going to help us perform the navigation. So I'm wrapping whatever I'm going to dump within that container using this stack.navigator that will essentially enable the navigations, right? So all that remains is to specify what are the screens, what are your screens, where are you going to perform the navigations, right? That is the only thing that remains at this point of time. So the way you do it is by calling this particular component, which is known as stack. Again, we use this instance of the native stack navigator, but this time, instead of creating a navigator, which we have already created, we need to create a screen this time. Okay. Now the screen navigator is basically a self-closing tag. All right. So now how are we going to specify what is the screen? We are going to specify it as a prop. So this is React code. This is not React Native code. We're going to specify it as a prop to this particular functional component. So that means I'm going to give it a name. So what is the name of my screen? It is going to be question screen.js, because that is going to be the first screen that will appear in the stack, at the very lowest section of the stack, right? So I'm going to give it a name. It will be called question screen. And then which component will be invoked when this screen is being visited? Well, it is basically this guy here, this question screen here, because it stores that file. All right. So that means I'm going to write down here component. Okay. And then curly brackets for JavaScript call. So I'm going to copy this guy from here, and then I'm going to dump it here. And then this will also show the header. Okay. Later on, when we kind of, drop this code in our stuff, there is options that you can provide for the screens that you are showing here. So there is one specific option that you would like to use here, and that is known as header shown. And then you set that to essentially false. Right. So what this is going to do is, since this is a screen and you have given a name to the screen, so when it loads on your application, right, when it loads on your device, it's not going to show a header and then your content. So this header shown false will prevent this name from showing up in the final render of your application, right? So this is the first screen. So now can you create the second screen in the same way? Yes, you can, right? All you need to do is copy this stack.screen, okay, and then paste it right below this. And all you have to do is now change these things and say this is going to be the answer screen. It's going to call the component which is stored in this particular object, which is basically the file for answer screen itself. And we are going to keep the header screen is false. All right. So with this, of course, we need some kind of way to go to the next screen, right? So that is also an important thing that you have to remember. This establishes the entirety of your navigation. Now, all that remains is to create triggers in each screen that will help us move back and forth within the navigation container, okay? But even at this point, if you run just this code, you should see the default screen. Let us just go ahead and test it and see if everything goes fine, or most probably we will get an error depending on how things are going today. But let's figure out what happens. Okay, and I'm taking I'm living on the edge by not deleting the previous state of my application here, but let's see. All right. Yeah, I'm living on the edge. So it's essentially showing me the previous state of my application itself. Okay, but coming back to the actual functional concept, and I'll address this in one moment. Let me just do one thing here first. Let me stop this server. Okay, and let me delete all of these guys here. And let me restart the server. And this time I'm going to use the QR code. All right, so what I was talking about. So what I was talking about here is this is all you need, those 3 packages that we installed at the very beginning. That is all you need at the beginning. And then once that installation is done, to repeat what we are doing, we will have, so you can see here at the very top, it says question screen here. Okay, we don't have a trigger within the question screen that will navigate to the next screen. So I will show that to you in the next class itself. But to set up your entire stack operation. Okay, this is where, guys, you can see here, since we don't have any style sheet that aligns it to the center of the screen, it is kind of bleeding into the danger area. All right, so 3 packages is all you need to set up your navigation. Bring in 2 different objects from the packages. First, wrap your entire application within this navigation container that will create the container itself. Then create an instance of the stack navigator, and then use the stack.navigator to set up the navigation. And then within stack.navigator component, use the stack.screen component to specify all the screens that you're going to have for your application, right? And then the only step to finish off the navigation process is now to go to these individual screens and then create some button or something like that, which will essentially allow you to go to the next screen and come back if you click that button and things like that. So I will show that to you, and we'll pick it up in the next class, and then we will move on to Redux to finish up this particular simple application that you're doing, right? By next class, please make sure that you install your emulators either in Xcode for iOS or in Android Studio, or at least make sure that your Expo Go app is working properly and that you can scan this QR code here and you can at least test out what you're doing in your applications, okay? And then we can move forward with this. All right, so we will wrap up here for today, and I will see you all again on Thursday morning. Thank you.